Hi, my name's David Cole. I'm Technical Director of Penstock Solutions, and I'm going to talk to you about spill control automation today. Well, spill control automation, really simply put, is the fact that you can automate a system that controls a spill. So instead of using human beings to react to a spill, you've actually got some automation involved in your system. Well, what we're looking at here is actually a system that's self-controlling itself. So when there's a pollution incident, instead of relying on a human being to go and operate a valve or control a valve or implement some sort of bund control, it's working from itself. So it's seeing a pollution incident linked to monitoring. So it might be linked to some sort of monitoring device, or might be linked to a fire alarm device. So immediately as something happens, the containment system, the spill containment system automatically operates itself. Okay, so let's just look at the automation and the maintenance and the activation side of this process. So what you've got is you've got an automated system that will respond to an incident. This may come from a fire alarm, it may come from a monitoring device, it may come from a human being pressing a button. Then you've got to look at how it actually records that, how it maintains what's happened. So what you're looking at is, I'm recording that somebody pressed a button and I'm logging onto a network, onto your smartphone, onto some sort of device, so you actually can see that who operated it, or where was it operated from, what caused it to be activated, at what time of day. So you're logging a time. So what you're creating here is now a schedule, so that instead of somebody saying, well, we had a pollution incident, I think it was at 3 o'clock this morning, and one of the guys went out and put a spill kit down, you've actually got a system now where it records that the piece of equipment was operated. You know that it was operated because it's told you it's been operated. You can see who operated it, so you know who you can go and ask, or where you can go and ask to find out what actually happened. But also then you've got a maintenance schedule, because you know that that piece of device was operated, so you know that you need to go and have a look at that equipment and check that it's okay, check that it's perhaps the pollution incident or whatever operated it is now back in spec. Because if that was coming from an interceptor alarm, for instance, which closed the valve, you need to know, is that interceptor now full of oil and we need to empty it, we need to arrange to get it emptied. So it completely automates your process, rather than relying on a human being at the end of it, seeing a pollution incident, operating some sort of device or going to respond to it, and then writing a log of when it was operated, which never really works in the real world. So when we look at it, this automation side of it, it's moving technology along really, because most of the world now relies on some form of automation. But what you've got now is, if your site does have a pollution incident, or for instance if you want to test this system, so if this system is a test operation where you actually want to close off your drainage or operate some barriers that you've got which are all set up as an automated device, what you're doing is you're creating a log, and if you're logging that particular event down, you're creating a maintenance record of when things happened. And I think if you've got a system that's automated, so it actually is generating a record of operation, who operated it, the regulator, if they were involved in an incident on your site, if you can show a record that actually is something simple to print off, that shows that every Tuesday you test your system and it's got a document, it's not relying on somebody just penciling something in, it's actually got some sort of computerized information, it goes a long way to proving that you've been in control all the time. So one of the things that I think we've moved along with automation of spill control is that the kind of current or the older idea was, you see a pollution incident, you react to it. What that's doing is that's totally reliant on a human being being qualified and skilled enough to actually react to an event. I think there's no sort of mystery in the fact that lots of businesses that we work with today don't have streams of maintenance personnel or engineers on site. These can be quite sort of like lean operations, where there may only be a security guard, production workers and a production process going on at any one time. So if there's an incident that happens, have you got anybody actually on site that could actually deal with that pollution incident? You haven't got time to pick up a phone, speak to a spill responder to get them to site. They could be hours away. You need to react very quickly. So when we look at spill automation, there's lots and lots of areas to look at. Now let's look at some of the sites that we've actually been involved with and we've dealt with. So we had one site that was quite compact and had an issue with vehicle washing, washing of a particular dirty vehicle. And the drainage was quite difficult to control. So the way they got around that, or the way we worked with them to get around, was we built in an underground tank. And that tank normally is just closed off, nothing happens with it. When they decide to wash a vehicle, There's one of our valves is fitted to this tank, and what it does is it closes one valve and opens another valve. So while they're washing the vehicle, all the materials, so they turn the vehicle wash on, the valves swap over and close. It closes off the surface water outlet and diverts any runoff then into this storage tank. It's a simple system, so that as soon as they operate the valves, it operates the vehicle wash. You can't operate either or. You can't sort of disconnect the our valves, and you can't disconnect the vehicle wash. You have to use them together. So if the valves go over and go into the closed position, which is the ready position, you couldn't turn on the vehicle wash, which is really a simple automation system to prevent mistakes. If you were relying on a human being that's got to go and close that valve, open that valve, it's open for an element of error. There's always a chance that the person will not operate the valves because it's easier and they can forget, well, normally it's okay, nobody ever notices. And just that once can be the incident that ends up with a pollution event. Then you look at other sites where you might be linking something into a delivery, whereas a delivery vehicle comes onto site, they've got a bypass key, that bypass key is interlocked into the control of the valves, you place it into the valves, you turn the key, that operates the valve. On operating the valve, you release your interlock key, which allows you to go and fill your tanker to make its delivery. These are all little simple effects that eliminate the reliance on a human being operating a system. It's back to a fully automated unit. And I think most of industry now, if we look at jobs and we look at how production works now, is the more and more we automate things, the more reliable they are, or the simpler they can become. Well, spill control and the automation side, A, is interesting because it's no longer just somebody running around operating a simple manual valve or perhaps a spill kit, which is all reactive. It's now become a bit more high tech and a bit more interesting. When you're building a new site, as soon as that site hits the ground, or it starts to look at permits and starts to look at how it's going to operate, the chances are they're going to be asked, what's your fire water containment plan? How would you control a major incident? So the interesting part is for us as designers and people building new sites is this can be done at the start. It can be done as part of the design process. So instead of waiting till you've built a site and then the customer applying for permits, this could just be done as a standard, always there, that it's just something simply connected into the fire alarms, into an alarm system. So if the site ever had an incident, it doesn't matter what they're storing, it's already developed, it's already in the site, is that the site drainage, the site pollution pathways can be closed down and there won't be a pollution incident for the customer already done. So spill automation and the control and the cost of it is quite a difficult subject to sort of cover in one quick statement. So what you've got is that hundreds and hundreds of sites now have adopted a pollution containment policy, a automated system in process. When you look at it from a new point of view, if you're building a new site, if you actually look at it and cover the latest guidance, so you're looking at how much liquid you might have to contain, you're building a policy up, and you're then building your drainage network, probably simply fitting a toggle block valve so they actually go onto nice flat faces and the drainage is being built correctly for what we're requiring and the above ground tertiary is correct. It's relatively quite simple and the costs actually are very, very low in the great scheme of building a whole new warehouse or factory. But if you then take that and don't do that, and you've now got a site that's got to be retrofitted, it can be quite difficult, and it can be, obviously the cost can escalate. You could already have an old existing pollution containment system that's been installed, which isn't automated, which is reliant on human beings to operate. These could be large Penstock valves that are in manholes that have been benched over in the biscuits and they sit in the middle of a road. To actually take those out and replace them with automated systems is difficult. So there's a big balance between, at the start of the process, if you take this, we need to think about containment right at the start because you don't know what might be on that site. That site might start off as a simple warehouse, but in 5 years' time it could be converted into a storage depot for drink materials, all sorts of, let's say, other materials that are more of a pollution issue. So your problem is that if the design wasn't thought of at the start, when somebody takes that over and then has to retrofit a containment system in place, it's quite complicated and that can be a lot more expensive. So if you can do it at the beginning and always think, let's just look at how could I contain this site, it's a lot simpler than waiting until a new type of application arises. Step 1 is understand the regulation. Step 2 is understand how that regulation specifically is to your business. Step 3 is to carry out a risk assessment of your business. Step 4 is to design an appropriate system. Step 5 is to implement that system that you've designed. And step 6 is to measure, maintain and document the system that you've actually installed and keep it up to date. If you've got any questions, please don't hesitate to contact me.